Assalamu alaikum everyone. So I have created this agentic chatbot using LangGraph. So in this I have included some features such as you can ingest your own documents. This module only supports PDF. So right now I haven't included the functionality of ingesting uh, docs, Word files, and other types of file formats. And this is the chatbot, and here I can ask it about the database and about the knowledge base. Basically, the vector database where we are ingesting our documents. So I have previously ingested some uh, documents regarding hotel policies and some hotel policies and some personal documents like my coding assignment in university and some other documents such as router, uh, a manual about router issues. So I can ask it about tell me the food related hotel policies. Okay, so it has told me there are special food related hotel policies. I will tell you about it. Yes, so this time it has given me some information. Dietary restrictions should be respected at all times. Breakfast must be served during the advertised hours, etc., etc. So and we can. So basically, this chatbot has two tools, the database tool and the knowledge base tool. Now I can ask for usernames from the database and give me username of all the usernames of it's taking a little time, so it has given me this. Okay, this front end that you can give custom instructions to your RAG RAG LLM, basically, not the chatbot, because chatbot is divided into multiple modules, which you will see and I will explain it. So this is the main file, basically, or should I start with the Streamlit front end? Okay, so this is the Streamlit file. It has these modules which I have imported, and basically this is navigation, and this is the page. If page is equal to this, then we do this, and is equal to this, and we do this. And if the page is equal to chatbot, then we run the function of the chatbot. And this is for ingestion, for ingesting the documents in the ChromaDB. So let's move towards this thing. Let's start yes, from here. Basically this is our function. This is a graph builder. I have used LangGraph in this, and we're adding some nodes. This is the first node, then we have other multiple nodes. This is the last node actually. So we start by the first node, or node actually, and this is basically a router agent or node. It will classify our query towards the whether we should use the database agent or the knowledge base agent. This happens when I will send my query through the chatbot. It will come over here, and it will classify it, and this module will check the decision, and if the decision is this, or it will go towards this. If it is this, it will go towards this. So now I have added the edges. Basically, this was the first edge, and then this was the conditional edge. These are edges. Suppose that if it chooses database agent, it will go to printout, and if it also chooses knowledge base agent, it will still go towards the printout output. And then when it reaches the print output, it will end the our graph. Yes, these are the inputs that I'm passing to the LangGraph, this workflow. So this is a type of system prompt, and this is some empty strings that I use in the further in the workflow. Now moving towards each of the individual functions. Let's see, this is the state that flows through the LangGraph workflow, and these are the basically I don't think that we're using this. Instead we're using the Streamlit session state instead of this. I think we can remove this, but anyways, let's go forward. And this is the query. When I ask the query, it will come over here in decision, and this is also used. All of these are actually used further in the workflow, as we will see. Okay, so starting from our first router agent, this is our router agent, and this initializes a list of messages using the Streamlit session state. If this Streamlit messages list does not exist, it initializes it, and it also initializes the context which is used for the LLM, as we will see further. Now this module, this prints the messages on the front end. We see over here this all the list of messages. Now if the user inputs a query, the query comes in this data member of the state class. Okay, so we write the query on the front end, then the session state, the query is appended as a dictionary to the session state of the Streamlit. Now what we're doing over here is that, okay, Streamlit session state, yes, we're setting the context, we're adding the previous messages and including this message that we have just sent through the chatbot, so that our latest message will come over here, the role and the content. As you can see here, this is for the next line, basically separating the messages, so that when we pass it to the LLM, it can basically see that they are it can basically differentiate or maybe read them more properly, or basically in a more easy way to explain things to the LLM. Okay, let's move forward. Clean response is basically when we send the response we get from here. This is sorry, I didn't explain this, forgot. Maybe move forward. uh, Model with tools. This is our LLM that we have initialized over here, and we bind these two tools to the LLM. So the router agent, it basically classifies between these two tools or agents. Basically they're tools, but we have just named them agents. So model with tools, we're basically sending a query in the form of a string to the LLM. Basically classifies the query and decides which tool to use, and the response comes here. And if we see that if it has made a response, this is something to do with tool calls. If there has been if it has decided which function or tool to use, then this code runs basically. So this will navigate to the name of the tool which has been called. If the clean response is this tool or this tool, we set the decision or in the state is equal to this tool, and we return the state. Else, if the model has if there hasn't been a call, basically I think if it hasn't been a call, else it decides the decision to be default, and we return the state. And this is for stopping the streamlet, I think. Yes, previously it kept repeating, making queries and running the code automatically, something like that it did. Now this is the conditional edge. It decides which tool has been called and just prints it on the front end. That's all it does. And secondly, does that it decides that to which direction should the graph proceed. So it does this as I have explained it. So now I will explain one by one these two tools. Let's go towards these. So first, starting from the database agent, I have created a separate database agent file from where I am importing some modules. From here, the generate query, basically the LLM will generate the query for the database, and then we will parse the query, and then we run the query basically. Maybe a few things in between also. We generate the query, pass the state, we get the query from the state. Basically in this function, I should explain this. So over here we have basically we are generating the query for the SQLite database. We send the query to the LLM. It basically gives us an SQL query. It can also return returns a single varied SQL query string for SQLite 3, no comments, no explanations. Then we pass we made the question we asked to the chatbot front end. It comes over here and only SQL inside these backsticks. So basically this first response, it comes over here, then we pass the first response in the second instance of the LLM, which is you are an SQL query analyzer that uses SQLite 3. You get the SQL query and you look okay, whatever. Sorry for the bad English. If it's wrong, you correct it without delivering any other talk other than the query. Here is the schema. We have passed the schema. Where is the schema? Here is the schema. Okay, pass the schema, and there is, if it's multiple queries, return a single varied SQL query string, no comments, no explanations. Basically it kinds of verifies the first query. and then it returns the final response, and we store it in the results. Now this module, this function, this basically parses the this function is for parsing the SQL query. Now this has been taken from, I took this from an AI tool. Basically I split lines. Basically its job is to return a parsed SQL query. I don't know how much efficient it is, but as long as my code is running, I am happy. Okay, so the next thing is that run SQL query. Basically query comes here in the state. It connects to the database which I have initialized through this file, and return to our code. It executes the SQL query, and it basically does some other things. Basically it takes the results and store these results in the SQL results data member. And yes, this is for doing this thing. If it's insert or update or delete commit changes. I think there is a problem with this. Yes, because it doesn't delete. As far as I have seen, it doesn't do this. So okay, let's move towards. So basically generates query, parses query, supposed to parse. Basically I don't know whether it does or not. This basically strips the code, the SQL query. If it consists of multiple lines, it strips those lines, as far as my understanding. And now this runs the query, and hence we print end database function. Now this is the knowledge base agent. It takes the state and returns the state as this did. It gets the context and passes the context to LLM, return state, and we will go into the detail of each one of these. Get context from vector database, basically the latest query. Get the embeddings, which I have imported from this file. No, not from a file, it's basically over here. I have another instance of it in another file, but it uses embed documents, not query. So we get the embeddings, print that we have made the embeddings, and we get the chroma client, where we get the collection, where collection name is this. Now we query our collection, we give it the embeddings, and we ask it to return us 10 results, and we get the results, and these results are navigated towards the documents in the result, and hence they are stored over here in the results. Now we get the results over here. Now we do one thing. Basically the set instructions, when I set the instructions over here, those instructions, they come over here because they are stored in the context file in the streamlet. Look at this, set instructions. I'm writing the instructions over in this basically text area. I can write over here and it comes over here. So a brief explanation of this, and basically it gets the user instructions. We will pass those to the LLM over here, and this we get the context, the history of the chat messages. Basically it is a string, as I have used it over here. You can see it is a string. So the this instance of LLM, it takes the context of our previous chats, meaning not other instances of chat but the same chat. It summarizes the chat and it comes over here, summarized context. We the and the last query also comes over here. Now we pass these, the summarized context, last query, and results from the database, vector database, Chroma database. And then we set a query: summary of previous chats, summarized context, retrieved results, and user query, the last query basically. And then we create an instance of an LLM. We get the model from a .env file. We set the messages. This is the system message. When you are an AI that adapts to user instructions, those user instructions that we were getting over here, they come over here to the LLM, and then we tell it to respond us like this and not like this. And over here we pass it a query, and we get the query over here in this answer, and hence we return the state. Coming back to the main file, now after these two modules, one of them is used basically, and they can't be used at the same time, and after whatever which one of them has been used, we come over here. And if the state decision is equal to database agent, we take the response and we write the response to the front end, and we append the response to the messages, state messages list. Okay, and that message basically is appended to the context string that is passed to the LLM the next time we ask something from it. Else, if the decision is not database agent, we write the answer, state answer, and again we append our dictionary of whatever the AI has given us, and we store it in the context string, and we return the string, the state. We return the state. So this is how this workflow is running. I know this is not production level. This is basically a very basic implementation, basic to mid-level implementation of a basic agentic system. So if you like this, please subscribe. If you like this, please subscribe and share this.